Hi everybody, today I'm going to show you how to make a animation similar to this. And what this is here is it's a simulation done using jet fluids, using the smoke solver, and it's got a singular emitter at the bottom and it's emitting smoke, and then there's also a radial field that is spinning it around as it goes up. And this was rendered in Redshift 3D using S26. And I've got another example here, which is the same thing, but just I put two of those same emitters in the scene and slowed down the radial speed so that it gives a bit more of a wispy, curling kind of simulation there, or rendering. Okay, so let's get started. I'm going to jump into S26. And I'm going to go to the plugins 4D menu and get a jet fluids scene. And from the scene, I'm going to add a smoke solver. Then I'm going to add a single sphere to this to be my emitter. I'm going to select that sphere and just move it down a bit, and also resize it to 30 so it's just a bit smaller there. And it's going to emit in my scene just from the bottom about there. Okay, and I want my emitter to be constantly emitting this smoke out of the top. And we don't need to add any velocity or anything here because by default the smoke is going to rise, and so it'll be rising up into the air anyway. But if you wanted to force it in a particular direction, initially you can use these velocity options right here. So I've got constant emitter, and in the smoke we have the object tab on the smoke solver, and down here you can see some of the information. So it's going to be using the gravity. It's going to have a buoyancy density factor for the smoke, very subtle to kind of would pull it down a bit eventually, and the temperature factors obviously pushing it out. And the temperature's also got a little bit of a decay. They both got a little bit of decay, but we'll adjust these to get a particular look later on. Now, before we can do anything else, we need to cache these externally. If we were to leave this internal, then we would only get the density grid from the simulation. What that means is you'd only get the basically the smoky part. You wouldn't get the temperature, the fiery part. To get the temperature and the density grid, you need to cache it externally to an external OpenVDB file. So you just set a path here, including the start of the file name that you want it to be. So I have a folder here called Jet Fluids Smoke Tutorial, and I'm going to call this Radial Smoke. And so the files that are going to get generated are going to be called radial smoke _000.vdb _001.vdb, etc., etc. So it'll export a separate OpenVDB file per frame. So with that done, let's just go and start caching, and we'll just kind of get a feel for how this looks. And if I bring over the file here, the folder, sorry, you can see that the files are being written out to disk. So I'm just going to let that run just for a few frames so that we can kind of then start experimenting with the look of how this is going to look with Redshift. So I think that's enough there. So to be able to render this, we need to add a Redshift volume. Now I'm using a Redshift menu up here. If you don't have this enabled, because in S26 it is turned off by default, you can turn it on by coming to Edit, Preferences, and under Renderer, select Redshift, and then just come down and choose, tick the option. As soon as I find it, Redshift main menu, this one here, make sure that's ticked, restart C4D, and then you will see this Redshift menu. You can get to these options elsewhere in S26, but I prefer to use this Redshift menu to keep it all in one place. Okay, so under here, I'm going to add an object, which is going to be a Redshift volume. And now we need to set the path to those files that we just had. So if I open up, and I'm going to select one of these files. And now under the animation tab, you want to change the mode to simple, and come down and press detect frames. And it's going to detect the number of frames that you have in that folder. Currently we have 42. if I was to do the whole simulation there, it would be 90. And because I know I'm going to actually be doing 90 frames later on, I'm actually going to set this to 90. What that just means is that when I now go past 42, there's going to be nothing in my scene, and now there will be. So it's expecting 90 frames, which we will have when we do the final animation. So with that set there, I come over to the volume tab, and you can see it's detected the two grid channels that this OpenVDB file has. One is density and the other is temperature. And we want to now render this in Redshift and put these in the right place to get that fiery, smoky look. So I come up to Redshift again, and under Materials, I choose Volume. And again, you can get to this from this menu here. You can go Create, Redshift, Materials, Volume. You can get it from there as well if you want to use this editor here. And so let's just double click that, open up the volume. And first I'm going to just actually drag and drop this straight onto the Redshift volume. So we're wanting that material on the Redshift volume there. And when we have this selected, we can now see a few channels in here. So the two channels that we're interested in are scatter and emission. So I'll just collapse the absorption. And I want to put the density into this one and the temperature into the emission. And to do that, the easiest way is to click on the volume, copy the name from that, come back over and paste it in, just to make sure you don't get any spelling mistakes. So we go to the volume, grab the name of that channel there, click back on the volume, and put this into emission. And I'm going to bring up the Redshift render view now. And I'm going to click the render button. And you'll see that it's all white. And what we need to do is now come down to the emission. Under emission mode, change the color ramp to black body. Now this is an addition that happened in latest Redshift version, which came with S26.1. And you can see this is quite bright now. To get that kind of same look that we had before, I'm going to set this to a number around 3,500. That's kind of getting closer to what I want. It's not exactly what I want yet, but it's closer to what I want. And I also want to add an environment map in here just to give it a little bit more color. It's under Redshift. And lights, dome light. Add a dome light to this scene, and I'm going to add a HDR image to the texture slot here. So I'm just dragging an HDR image in there, and I'm going to turn off the background. At the moment it's going to be just a subtle difference, but it makes it look a little bit better once we actually can visualize the smoke in here. So that's the next point here really, is we're not seeing any smoke. And the reason there is because if we go back to the grid smoke solver, click on the object tab, the temperature is kind of not diffusing anywhere. It's not dissipating or anything. So we need to put up a little bit of a decay in there, and we want to diffuse it out a little bit as well, and we'll get a nice kind of glowing effect out as well. So we want a bit of decay is what we want. We want it so that it doesn't go all the way up like the smoke is going. So I'm going to change this to a value of 0.02. Now these numbers are very tiny and fiddly, and I haven't adjusted these yet to be any kind of default factors. I've just left it as they are, because you can play around with this. But if you were to bring that right up, you'd get. It's okay to play with the slider as well, but they are very subtle. Can be very subtle with the numbers. So it's kind of easier to just adjust them manually, very fine tune them. So again, I've just added the density factor. So let's just see what that looks like. If I come over to cache, clear it, and we're going to start caching that again. And I'm just going to hide the sphere. I'm just going to see what this looks like after a few frames. Because it'll require, probably about 40 frames before we'll start seeing the smoky part of it. And you can see it there. You can see it's darkening now. It's getting a lot darker at the top there. And if I was to come back to the Redshift volume, and maybe I'll bring that temperature down to maybe 3,000. And now we're seeing a bit of more of the smoke. It's getting closer to the other render that we showed at the beginning. Because that's close, so I'm going to now stop this. And I want to change the diffusion coefficient to kind of have it looking real hot and glowing, and kind of the fire coming out the side there. So I'm going to change that to 0.1. And now let's recache that. Now you're seeing the glow come out of the fire there. And that's closer to the original animation that I showed as far as the look goes, the color. So I'm quite happy with how that's looking right now. So now I want to put a radial field in here and have that swirling around. So let's press stop on that. And you'll notice when I'm doing this, I'm able to get interactive feedback in the render view here, because the way I've got this set up is the render view is using just the GPU. It's not using any of the CPU. So this is a 10-core i7 machine with a single 1080 graphics card, and under the edit preferences redshift, I've got it set so that this computer is only using the graphics card for the rendering for redshift. And I've turned off hybrid rendering as well, just to doubly make sure it's not going to try and use the CPU for anything. But if you don't have a GPU redshift license, like if you just have plain S26 and no specific redshift license, or you don't have the Maxon one, then you can also render this using CPU as well. And so it'll use CPU, and you'll get the exact same look. It'll just be a little bit slower to do the renders. But if you have a graphics card and you have the GPU rendering, you can do this interactively, and they're not competing for any kind of resources, which is quite nice. So the way I've got it set up here allows the jet fluids, which is CPU only, purely CPU, to use all of my 10 cores, 20 threads on my GPU, on my CPU to do the simulation, and then the graphics card has the full resources, or Redshift has the full resources on my graphics card to do the rendering. So it works quite nicely to do the simulations and preview the effect at the same time. Alright, so now I want to get to that radial field. So I need to first click on the grid smoke solver, and then under the forces tab down here, hold down on that and find the radial field, and it will add a radial field to our scene. And I might just close this, and I'm going to dock this just to the side there. And the radial is added to the origin of the scene, and the jet fluids is actually pushed across from the origin, so that one corner is actually at 0, 0, 0. So we want to move this radial field into the center of that box. So to do that, just select only the radial field before the grid smoke solver is selected as well. So just select just the radial field, and then we can just move that across by the dimensions of the grid smoke solver itself. So the grid smoke solver is actually set to be under the object tab 200, 200, 200. That's the size of this in world space. So I've just moved it over by 100, 100, 100. So now it's directly in the center of that fluid domain. And let's go back to the grid smoke solver again, and under the forces tab, by default it's applying the gravity force. And what will happen is every single frame it's going to be applying this force from the radial field in the direction according to the settings that you've got for the field itself, because you've got a lot of additional functionality here to remap and adjust how this comes out. But I'm leaving those as the default, and I'm just going to set my strength multiplier to a value of 1. So it's going to put a force of 1 coming out from the radial field, and it's going to constantly happen every single frame. So this is going to start slow, and then it's going to get faster and faster. And you can imagine like putting a spoon in here and spinning around. You're going to create that vortex. And one way you could adjust this a little bit better as well is you could add multiple fields in here, and you could have some that subtract forces from the volume, or from the effect of this of these forces at least. So you could put other forces in there, and play with this menu as well. But we're just going to leave this right now as the single radial field. So it's going to emit a radial effect of 1 and in this volume and start moving this smoke around. And with that set, I'm just going to come over to the cache tab, clear what I've got right now, and start caching. So now what we should see happening is the smoke slowly start turning around, and you can kind of already see it moving a little bit there. Starting to spin it around. So it's kind of doing what we want here, and the render is looking quite nice. So what I'm going to do now is just pause the video and let it complete those entire 90 frames. Alright, so it's just about finished there. It's coming down to the last final frames. You can see it's been whisked and turned around there. And now I can kind of scrub back and forward there and see how that's looking. Alright, so that's basically it. That's rendering that smoke effect using redshift volumes and redshift volume materials with a radial effect in there. And if you want to just experiment some more, you can just come in and you can just play around with these little numbers, just adjust them slightly. Don't do massive numbers in there, and you'll get subtle effects in here of how it affects your simulation. And if you want to play around with getting faster feedback, you can increase the cell size. If I increase that to 8 or 10, you can get kind of a faster idea of what's going to happen to your scene. And then when you want to have more resolution, you can just start lowering that down and just set it to simulate over a period of time. Walk away from your computer, come back, and then you can start checking it out. So those 90 frames there to simulate this, it took, we come up to extensions console, and under jet fluids, you'll see at the bottom here, it took 120 seconds. So 2 minutes to simulate 90 frames.